Module 5, Lesson 2 deals with real numbers. Our content objective is that students will identify and describe sets of numbers in the real number system, and our suggested pacing guide says we're going to knock this sucker out really, really fast, which is always a nice change. Now we're going to start out here with a little infographic about irrational numbers, which don't be confused with irrational women, boys, because boys, there is no such thing as an irrational woman. Trust me on this. Never ever tell your wife she's behaving irrationally. It is not a good idea, but I have digressed. Let's take a look at some information about irrational numbers. Scroll out just a little bit. An irrational number is a real number that cannot be written as a fraction. That's an important thing here. It cannot be written as a fraction. Commonly, the word irrational means not logical or reasonable. Like of course, as I said before about never tell your wife she's not behaving logically or reasonably. Bad idea, boys. Just bad idea. Trust me on this. For example, why is there a snail here? I have no idea what that has to do with that and why this snail even cares about glasses, but I have digressed. Irrational means not rational. Now we've already described a rational number before as a number that can be written as a ratio of two integers, otherwise known as a fraction. An irrational number cannot be written as a fraction. No matter how hard you may try, it can't be done. The decimal goes on and on forever without repeating, and in that you have the basis of what an irrational number is. An irrational number is a non-terminating, non-repeating decimal. If it can only be written as a non-terminating, non-repeating decimal, it's an irrational number. Some of the famous irrational numbers over there is going to be the fraction. Famous rational numbers can be any fraction. For example, 16. It's 16 over 1. It can be written as a fraction. On the 9.2, terminating decimal. It's 9 2/10. It can be written as a fraction. 0.333, repeating. It's a repeating decimal. It can be written as a fraction. However, on the other side, you've got pi, which is 3.14159265, and so on. Totally irrational. It never repeats, it never terminates, it just goes on and on forever. And then we have pi's lesser known cousin, phi. How lesser known is it? Well, I've never actually heard of it referenced as phi, but we have talked about the golden ratio before, and the golden ratio is an irrational number, non-terminating, non-repeating decimal. The Euler number, another thing I've never heard of here, is best known for its use in many mathematical formulas. For example, you use it when calculating compound interest. Once again, it is a non-terminating, non-repeating decimal. Square roots, some square roots can be rational. The square root of 4 is 2. The square root of 9 is 3. Totally rational. However, the square root of 99 and the square root of 3, totally irrational. They are non-terminating, non-repeating decimals. A root that is called irrational, that is irrational, is called a surd. I have never heard that. See, even I learn things. I wonder where you actually use that. A surd. Can't see that coming up in common conversation. Now, this is irrational. It has been said that the ancient Greek philosopher Hippasus discovered irrational numbers when trying to write the square root of 2 as a fraction. Instead, he proved that you couldn't write the square root of 2 as a fraction, and it was irrational. But fellow mathematicians thought the existence of irrational numbers was outrageous because their world was based totally on rational numbers. They had not gotten to that irrational state yet that we're fixing to dive into when we get into this lesson. Our inquiry question wants to know what different types of numbers can be found on a number line. And we're going to use some e-tools to explore this question. Now we're going to use the point tool to graph these various numbers. So first off, you got 4 1/2. So 4 1/2, going to put a dot here. That's going to be about right there. That'll be 4 1/2. Let's pick a new color here. We're going to do -7, which -7 is going to be right about there, and pick a new color. And then we're going to have 0.15, 0.15. That's going to be pretty hard to get precise. I'm going to say it's going to be about right there. And then finally, we're going to take and do the square root of 25. The square root of 25, that is actually going to be 5, so we're going to put it right there. I wonder if this is going to check, and yep, they landed right at about the same place I did on mine. Now, all of these points that we've just graphed are rational numbers because they belong to terminating or repeating decimals. Also, they can all be written as a fraction. Irrational numbers are located on the number line as well, but it's kind of hard to put them in the exact spot because they're not exact numbers. They go on and on forever. The decimal expansion of the square root of 6 now is going to be shown. What do we notice about the decimal expansion? Well, we notice that it is an irrational number. It goes on and on forever throughout time and eternity. How could you graph the square root of -6 on a number line? Well, can be about a ballpark answer. We're looking for a number that is about 2.449. You can see here we got 2.4, here we have 2.5, 2.44. Well, that would be 2.45. So I'm going to say about right there. And to check the answer, theirs was close, but a little bit more to the right than mine was. But you can see how it would be impossible to graph an exact location of that number on the number line. So how about this one? Where are these each going to land? On the left we have rational numbers, otherwise known as numbers that decimals repeat or terminate. And on the right we've got irrational numbers, otherwise known as numbers that never repeat or terminate. So that one terminates, I said that one terminates, and that one terminates. Come on, say there. -1/3, it's a fraction, it'll be there, and from there we're going to have a little bit harder time. Now this one here they show us is a non-terminating, non-repeating decimal. It's going to be irrational. A non-terminating, non-repeating decimal, that's going to be irrational. And this one here, non-terminating, non-repeating decimal, it's going to be irrational. Now we already discussed in the very beginning that pi is also a non-terminating, non-repeating decimal, and that leaves us with the square root of 144. The square root of 144 is, it's 1.2. 1.2 is a terminating decimal, so it goes in that side. Everything checks. Real numbers are numbers that can be found on a number line. That's a vocab term, and we're going to watch this animation to see examples of some real numbers.
Real numbers are numbers that can be found on the number line. For example, the integer -1 is located here. The decimal -4 and 5/10 is located here. And the fraction 3/4 is located here. Pi can also be found on the number line. First, you need to approximate the value of pi. Pi is approximately equal to 3 14/100. So pi is located close to 3 on the number line. The square root of 21 is also a real number. It is approximately 4 58/100, and so it is located a little more than halfway between 4 and 5 on the number line.
Now I should point out that both pi and the square root of 21, those are irrational numbers. The other three, those are rational numbers. Real numbers encompass both of them. Anything that can be put on the number line, that's going to be a real number. However, rational numbers and irrational numbers fall into that category. Therefore, they are both real numbers. Real numbers are either rational with a decimal expansion that terminates or repeats, or irrational, as I just said. And an irrational number, we're finally defining it, is a number that cannot be expressed as a ratio of a over b, where a and b are both integers and b is not equal to 0. Vocab term. Irrational numbers have decimal expansions that are non-terminating and non-repeating. Now, we say non-repeating. I want to make sure you understand. For example, here, yes, 8 occurs 2 times there, But in the end, it is a non-terminating, non-repeating. There's no real pattern in these numbers. And because there's no real pattern to them, then it's not going to be repeating. Now right here it did give you 0808, but I'm pretty sure if we was to find the square root of 3, we would find other random numbers going into the pattern there. Now if you were to take a look at this Venn diagram here, you can see that real numbers include your natural numbers. Remember, your natural numbers occur in nature. 1, 2, and 3, they're things you can hold and keep and love, okay? I always tell the story of caveman days. Caveman can hold 1 sheep, caveman can hold 2 sheep, 3 sheep are going to keep caveman warm at night with all their wool. But if caveman has 0 sheep doesn't occur in nature. 0 sheep are not going to give him any wool to stay warm with. So 0 sheep is not a natural number. Whole numbers are natural numbers with 0 added into it. That's the only difference between whole numbers and natural numbers, is whole numbers have 0, and integers are the natural numbers, 0, and the opposite of natural numbers. So for example, 1 and -1, 2 and -2, 3 and -3. All those are rational or integers. Outside of that category, you have rational numbers. Rational numbers are going to be able to be written as a fraction. They are going to be either a terminating or a repeating decimal. And the last category, all over there by us, we would have wants them. Nobody loves them. It's so sad. That's going to be your irrational numbers. The irrational numbers are your non-terminating, non-repeating decimals, and they cannot ever be written as a fraction. Now it's time for us to start identifying whether something is rational or irrational. They started off with -25. Can -25 be written as a fraction? Absolutely. It's -25/1. Is it a terminating or repeating decimal? It's terminating. It ends at -25. And the textbook would also argue that it is a repeating decimal because you have all those zeros repeating after the decimal mark. So, answer each question and determine if it's rational or irrational. Can it be written as a ratio of A over B? Absolutely it can. That one's going to be correct. Go to the next. When written in A over B, are A and B going to be integers where B is not equal to 0? Yes, again, because that is going to be -25/1. So A and B are both integers, and B is not going to be a 0. Therefore, we have ourselves a real live legitimate rational number. Since -25 is equal to -25/1, -25 is a rational number. Check it. We get happy sounds here. Moving on to the next slide with this, -25 belongs to what other set of numbers? Along with rational numbers, it is also going to be a real number. It's also going to be an integer. It's not going to be a whole number though, nor is it going to be a natural number, because -25 sheep, cold caveman is going to be very cold at night. Now this is an extra example, so it's supposed to be one you guys do, but we're going to go ahead and do it together anyhow. The square root of 20. Is it rational or irrational? Well, 20 is an imperfect square. That means there's no two numbers that we can multiply times themselves to get it. It also means we have to use a calculator to find it. So I typed in my 20, and I'm going to hit my square root button, and look at all those numbers. Can y'all see all those numbers? Let me zoom way in on that, maybe. Nope, it's not going to let me zoom in now. Well, that's so sad. So you've got all these different numbers here that is non-terminating, non-repeating decimals. But check that out. 9 occurred 3 times in a row. It's still a non-terminating, non-repeating decimal, because after that, it's a while before we see more 9s, okay? It's a non-terminating, non-repeating decimal. Since it's that, it's going to be irrational. You could also say that it could not be written as a fraction. I think that's going to be a good spot to stop for part 1. We will come back to see part 2 in just a little bit, where we start to classify some real numbers. I'll see you when we get there.